Hello everyone, good morning. So I welcome everyone to my YouTube channel. So in previous sessions, right, so till now we have conducted some 24 sessions on matrices. Previous 24 sessions, if you go to my channel, you will find the playlist of matrices in which we are having 24 sessions of matrices. Alright, so we have taken 24 sessions. It was a concept of around 9 hours, 8 to 9 hours. So we have taken nearly around 13 to 14 hour session divided into 13 to 14 hour concept divided into 24 sessions. Right, now based on the matrices, right, so we are going to start today's concept, that is nothing but determinants. So what is the today's concept? It is determinants. It is the base, it is based on matrices. Right, so if you have the proper knowledge of matrices, then you can easily breeze through determinants. Okay, so before starting the concept or before starting this unit, let us have a look at your marks distribution. Right, this is for your Karnataka PUC second year marks distribution. Okay, so totally you are going to get 4 questions from this unit. Right, that is from determinant. You are going to get totally 4 questions. Okay, so totally 4 questions. One from 1 mark. This will be in part A. Okay, so in part A you will get 1 question of 1 mark, and in part B you will get 1 question of 2 marks. Right, in part A you will get 1 question of 1 mark. In part B you will get 1 question of 2 marks. So total marks count in part B is 2. And next is you will not have any 3 marks question here. There is no 3 marks question in determinant. Right, so you will not get any question in part C. Right, that is from 3 marks you are not going to get any question. This is from part D, where you are going to find a question, 1 question of 5 marks. You are going to find 1 question of 5 marks, and this 4 marks question is from part E. That is from part E. That is the last question. Right, in part E what we are having, it is totally 2 questions carrying each 10 marks. So each question will be of 10 marks, and each question will have 2 subdivision. One will be for 6 marks, another will be for 4 marks. So this 4 marks is coming from that session. Right, so totally how many marks we get? 1, 2, 3, 3 plus 4, 7, 7 plus 5 is 12. So totally we are going to get 12 marks on this determinants, which is very easy. Right, if you just listen this thing and if you properly understand what is the matrix, right, then there is absolutely no confusion here. Then it will be very easy concept, and easily you can get 12 out of 12. Right, so what is the prerequisite for this? Proper understanding of matrices. Prerequisite for this is proper understanding of matrices. If you understand matrices very well, that is more than sufficient for this determinants. Okay, so let's start with the determinant. Coming to introduction. Right, so why do we use determinant? What is the difference between matrix and determinant? As I said in introduction class of matrix, right, so matrix is used to represent more and more terminologies. Right, in a small available area. Right, I have given an example of bus, people sitting in a form of row and columns. Right, so if you arrange the people in particular rows in the form of rows or seating arrangement, then only maximum number of passengers can be accommodated. If you try in any triangular pattern or any circular pattern, that may not be possible to accommodate. It may not be possible if you people to accommodate more and more passengers. So to represent more and more information, we are using matrix. And one more application of matrix is we can use this matrix to represent the equation. That also we have seen. It is very useful to represent linear equations. Okay, so let us consider a pair of linear equation. a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. Both are linear here. Right, so these 2 equations we can express in the form of matrix. a1 b1, a2 b2, xy is equal to c1 and c2. Right, if you cross multiply, once again you are going to get the same equation. Right, first row with first column, what you are going to get? a1 into x, that we are having here, then b1 into y. So first row first column will give me a1x plus b1y I am having here. and that will be equal to what? C1. And second row with this one, a2x plus b2y, right? In the second row you will get a2x plus b2y, and that should be equal to C2. So that's what we have here, right? So this is how a linear equation, pair of linear equations or set of linear equations can be expressed in the form of matrix, right? Now this was all about matrix. Then why do we use determinants? What is the use of determinants? Okay, so here, in order to find the value of x and y, it is compulsory for us to solve these equations. If we solve these equations, then only we are able to find the value of x and y, right? These x and y, it is possible to find the values only if we solve them, right? But what is the problem in solving the equation? We don't know whether it is going to give you a proper solution, whether one solution exists, two solutions exist. There are many criteria. If you solve any pair of equation, right, it is like that you may not get any solution, fine. Or it may also happen that you may get multiple solutions, or you may get only one solution, or we call it as unique solution, right? How to identify? How to identify that a system of equations, we call these as, this set of equations we call them as system of linear equation, right? So the system of linear equation, whether it is having unique solution or not, how to find them? That is with the help of determinant, right? If you make use of determinant, then easily you can judge, right? Easily you can judge whether this system of solutions, system of equation is having unique solution or not. How? We have a standard form, right? If this, we are having two set of equations, then a1 by a2 should not be equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, then there exists a unique solution. If a1 by a2 is not equal to b1 by b2, then there exists a unique solution, right? If it is equal to a1 by a2, if a1 by a2 is equal to b1 by b2, then there may exist multiple solution, right? Or it may be the condition that we may not be able to judge the pattern, right? So if we need unique solution, then a1 by a2 should not be equal to b1 by b2, right? Or I can write, if I cross multiply, a1 b2 is not equal to a2 b1. a1 b2 is not equal to a2 b1. That is the meaning of this equation. Or I can also write a1 b2 minus a2 b1 is not equal to 0, right? It's not equal to 0. If I shift out on the other side, what I will get? a1 b2 minus a2 b1, and that is not equal to 0. If this condition is satisfied, then we can say that this system of linear equations is having a unique solution, right? And what is this called? If you substitute a1, a2, b1, b2, these are all the numbers, right? Inside the matrix, this will be the numbers inside the matrix. So if you substitute them, then you are going to get some number. You should get some number which should not be equal to 0, either 2, 3, 4, 5 something, and that value we call it as determinant. That value we call it as determinant. Or in general, a1 b2 minus a2 b1 is nothing but the determinant of this matrix. Is nothing but determinant of this matrix, and it is always associated with this matrix. Is that clear? And it is always contained in this matrix. From where did we get this a1 b2 minus a2 b1? That is from this matrix only, right? So that number is always contained in this matrix or obtained from this matrix, right? So that number is called determinant of this first matrix. Determinant of this particular matrix. Is that clear? Okay. And one condition here is determinant can be calculated only for square matrix. Determinant can only be calculated for square matrix. You cannot calculate the determinant for rectangular matrix. That is, for non-square matrix, you cannot calculate the value of determinant. Why it happens so? If 2 rows and 2 columns are there, then only, if number of rows are equal to number of columns, then only we call it as square matrix, right? Here how many unknowns are there, x and y. How many equations are there? 2 equations, right? So if you are having one more equation, a3x plus b3y is equal to c3, then what are the unknowns? For example, if you are having one more equation, a3x plus b3y is equal to c3, then what happens? One more term will come here, one more row will come, then this becomes a rectangular matrix, right? There is 3 rows and 2 columns. Okay, why it is not possible to find the value of x and y here? Why it is not possible to judge the value? Because we have 3 equations. How many unknowns? 2 unknowns. So it's not possible, right? So it becomes difficult. So in general, what we do here, alright? So if it is not a square matrix, then number of unknowns will not be equal to number of equations, right? Number of unknowns may be less than the number of equations. Number of unknowns may be more than the number of equations. So in general, if I want to say number of unknowns will not be equal to number of equations, so it will not be able to estimate the values of x and y, whether they are unique, right? If it is unique or no, we cannot say if number of equations are not equal to number of unknowns. So we can only say about uniqueness of the equations only when number of equations are equal to number of unknowns. When number of equations are equal to number of unknowns, it is definitely a square matrix, right? It is definitely a square matrix. Okay. Okay, fine. So I hope the things are clear here. So what you should understand is it should definitely be a square matrix. Then only you can find the determinant value. If it is not a square matrix, we cannot find its determinant value. Alright, this was meaning of determinant and background of determinant. Okay, background concept of determinant. Now what is its definition? Alright, as I said, it is a number. What is determinant? a1 b2 minus a2 b1. What is that? It will be a number. And from where we got that number? From this particular matrix. So determinant can be defined as a number associated with every square matrix A. If you consider A as any square matrix, right? So it is a number associated with any square matrix A, right? So if A is equal to A, B, C, D, then the determinant of A is written as A with this symbol, and don't confuse this symbol. This is not mod. This is not mod. This is called as determinant, right? And it is written as determinant of A. And what is determinant of A? It can also be written as det of A, that is equal to A, B, C, D in the symbol of mod, but it is not mod. It resembles the symbol of modulus, but it is not the modulus, right? And it can be calculated by how? A into D minus C into B, or B into C. Cross multiplication. AD minus BC. This value will give you the determinant, right? This is nothing but determinant. So this was about introduction, right? And marks distribution, everything. So you pause the video, take down this definition and all, and if you need, you can also take down this one. Okay, pause the video and take the notes. Friends, I hope you have understood the concept here. So what all we have discussed? Firstly, we have discussed about the marks distribution or examination pattern, right? Next, I also informed what is the prerequisite for this unit. Thirdly, we have started this one, introduction. What is the actual meaning of determinant? Why we need to calculate determinant? Everything is in short explained here, right? Then its definition, meaning of the definition. What is the definition? Everything I have explained. Right, in this introduction session I made the concepts, I think, very clear, right? So now what you need to do is you should go very carefully, you should concentrate it, right? Carefully listen to the session. If you have any doubts, you can, as usual, you can revert me back, right? So this was the concept of introduction. So we'll stop this session here. In the next session we are going to see how to calculate the value of determinant. So if determinant is of order 1, or if the matrix is of order 1, how to calculate its determinant value? If we have order 2, then how to calculate its determinant value? If we have determinant of order 3, then how to calculate it? As per your syllabus is there, determinant is restricted only up to third order. As we have seen matrix only up to third order, determinant is also restricted to only third order. We are not having fourth order determinant. Okay, so we will see them clearly one by one. Now what you should take care here is, two things should be very much clear. This symbol is not the symbol of mod. This symbol is not the symbol of mod, and you may get the negative values also. Alright, in some cases you may get negative value, in some cases you may get positive values. Don't confuse that the values are in the mod, definitely we should get the positive value. No, it's not. Right, this is not the symbol of mod, this is the symbol of determinant here. Okay, and secondly, determinant can only be calculated for square matrix, not for rectangular matrix. Okay, so these 2 points should be very much clear. Right, so we'll stop here. We'll continue in the next session with process to calculate the values. Okay, we'll stop here. Thank you.